differentiation. So we are going to differentiate y with respect to x. We have y here equals to an expression with x. Right, below here we have the same thing. Here we have it, but I'll show you where it is. Below we have y equal to something involving x. So we have to differentiate y with respect to x, right? WRTX with respect to x. Now, sometimes you might see y equals to whatever expression, or you might see f of x equal to whatever expression, right? And also, if we differentiate in y, we use dy dx, right? So dy simply means we differentiate in y with respect to x dx. And we can also say y prime is the same thing. Dy dx is equal to y prime. And since y equals f of x, we can say f prime x, right? F prime x simply means dy dx as well. If we were to differentiate it a second time, let's just see, right? We would have d2y over dx squared, right? So here, if I zoom it, right? Here we have dy dx, come like we say d1y over dx to the power 1, but we don't write 1, it's understood, all right? If we have y prime, and we differentiate in y prime again, we can just simply say y double prime, or if we differentiate in f double prime x, right? Same thing. So let's get on to business one time. We are going to use these rules, right? We are going to use these rules, and we are going to differentiate these questions across here. So part one, we have y is equal to x to the power 33. So if you look at this rule here, when you differentiate x to the power n, you put n in front, so you multiply n by whatever number. In this case, the number is 1. It's understood. It's understood. You have a little 1 here, right? Just remember that. All right, so n multiplied by 1 is n, x to the n minus 1. So it simply means whatever power you have here, you subtract 1 from it. All right, so let's look at this question here. If you differentiate in y, we will simply say dy dx is equal to 33 times 1 is 33. And we put x to the 32. Where you get 32 from? 33 minus 1 is 32. One time. Now, I mean, you can probably say dy dx is equal to 33 x to the 33 minus 1, right? And then write this line. You can do that, right? But when you get more complicated questions, you need to do it like this. You need to think of it like this and work out the answer one time. You don't have time to do this, and putting too many steps like this can confuse you, your working, all right? Next, y is equal to 1. Now, you're differentiating y with respect to x, but here we're going on, you're not seeing an x here, all right? So I'm going to tell you where the x is. So it's like you have y is equal to 1x to the power 0. Any number raised to the power 0 is 1. Right, you have to remember that. You can check out my laws of indices video, and that deals with that there. All right, so when you differentiate this here, dy dx is equal to, you say, okay, 0 by 1, because remember, whatever power you multiply by the number. So 0 by 1 is 0. X to the 0 minus 1, which is x to the minus 1. Just writing it for emphasis. But any number multiplied by 0, right? And 0 multiplied by anything is 0. So your answer here would be 0, right? So usually I tell students, when you're differentiating a constant, the answer is 0. Why? Because of this here. You will always, because when you differentiate in a constant, what it is respect to, because in this case is respect to x, it could be respect to v, t, right? But in this question, in respect to x, whatever variable it is, that variable will be raised to the power 0. When you differentiate that, you get 0. So you don't have to do all of this working. Anytime you see y equals a constant, just put 0. That's the answer. dy dx is equal to 0. So I would write here dy over dx is equal to 0. And I know y. This is my y here. Just now. Right? This is my y, not y, right? Let's continue. So we have y equals to x over bracket 2x plus 4. So make your life easier, right? Now there's something called product rule. You could do that there. That's long. Or you can make your life easier and expand the brackets. Later on the next video, I'll deal with product rule and quotient rule. All right. So you expand. Now the only reason you can expand this bracket one time is because you have a power 1 here. If you had a power 2, you had to deal with the brackets first, then expand it. So that's something different. But since you have a power 1 here, you can expand the bracket. So let me zoom in. Y is equal to 2x squared plus 4x. Right, you expand the brackets. And we are still going to apply this here. So we are going to differentiate dy dx, but we differentiate in this term. And when you finish with that, we differentiate in this term. Now we're not doing it separate, we're doing it one time. You could do it separate if you want and then put it all together, but that is time consuming. And if you get a complicated question, too much working might not be in your best interest, right? You need to work certain questions in your head, certain parts in your mind, and put it down, right? Because you might confuse yourself with too many steps. So let me use y prime, because y prime is like saying dy dx. Y prime is equal to, remember here, we say, okay, whatever power we multiply in front by the number. So 2 2s are 4. X2 minus 1 is 1. So we know it's understood. I don't have to write the 1 there, but let me leave it there. You don't have to write the 1 because x to the power 1 and x is the same thing. All right, plus, so we have 4x, right? So 4x, when you differentiate 4x, you will get 4, right? Because if you have a number 1 here, 1 times 4 is 4. And then you have x to the 1 minus 1 is 0. And we know x to the power 0 is equal to 1, right? So you could write 1 here, right? You can write 1 here if you want, and then say, well, y prime is equal to 4x plus 4, right? You do have to do this. Just differentiate, get your answer here one time. This extra step, not necessary. All right. Continuing, I just want to point out, if you had y is equal to 2x to the 5 minus 1, and in a bracket, and this is raised to the power 1, or you just have it in a bracket like this, right? You can just simply just put it like this and differentiate it normal, like how you had, how we differentiated, or how I differentiated up here, right? But because you have this power 3, once the power is not 1, right? Because it could be -2, it could be 4, in this case it's 3, right? Once it's not +1, right? We are going to do this step, okay? Let me just erase this first. So dy over dx is equal to, we are still using, let me zoom out a little bit. We are still using this rule here, x to the power n, right? So come like I'm treating this as x to the power n. It's come like I'm treating it. So I'm multiplying the n by whatever number in front. In this case is 1. I'm subtracting 1 from the power, but there's an additional step, right? So let's deal with that one time. So I'm going to say, okay, 3 times 1. I'm dealing with the outside first and then go in, all right? So I'm dealing with the outside first. So 3 multiplied by 1, which is 3. I write back what's in the bracket. And then I say, okay, 3 minus 1 is 2. Nice. And then I continue. I deal with the inside now. So I have to differentiate what's inside. So you have to multiply, right? Always multiply, right? Multiply after. So we have, when you differentiate 2x to the power 5, 5 times 2 is 10. X, 5 minus 1 is 4. Minus, remember when you differentiate in a constant, it's 0, right? It's 0. So, I mean, you could put minus 0, right? But that's wasting time. So once we know when you differentiate in a constant, it's 0, just close your bracket one time, right? Close your bracket. And then you simplify. Simplifying is very important. So I like to write one term, right? If in this case I have x to the power 4, it's less complicated than this. So I like to put this first. If you have this first, this second, it doesn't matter. It doesn't matter at all, unless the question tells you to prove that something equals something, then you have to put it in the specific way that the question asks. So 10 times 3 is 30. I put my x to the power 4, 2x to the power 5 minus 1 squared. This is the answer here. All right. So we did 4 so far. Let's look at this one. All right, let's look at this one. So we have y is equal to 4 root 6x to the power 4 minus 1 minus 4. All right, so let me deal with dy dx. But before I deal with dy dx, I want to make my life easier. So this square root thing happening here, the square root symbol, right? I'm going to write it like this. Right. The square root, if I have the square root of 4, square root simply means you have a 2 here. And this is equal to, right, 4 raised to the power of a half. Now, if you had a 5 here, then you would have a 5 there, right? So it's, if you had the fifth root of 4, then it's 4 raised to the power 1/5. If let's say you had pi here, then here you're supposed to have pi. All right, so this here is very important for you to know to change this to this form in order for you to differentiate. All right, so let me erase this. Continuing, dy dx, same thing. We deal with the outside and then we go in. 4 times a half times 4, because whatever is the power, you multiply by the number in front. A half times 4 is 2. You write back what's in the bracket. A half minus 1 is negative a half. And then you have to differentiate what's in the bracket. So when I differentiate 6x to the power 4, 6 4s are 24, x to the power 3. Remember, 4 times 6, 24. Go back the x, 4 minus 1 is 3. Minus, when you differentiate in 4, a constant, you get 0. So we just close bracket one time and we simplify. 24 times 2 is 48. Right, so this here is your answer. Now, if you can write this question like this, because if you're proven and they ask you to write it a particular way, you have to know how to transpose, how to manipulate the equation. All right, so I can rewrite this like this. Right, negative a half means like, okay, the initial position really is supposed to be the denominator, so that is why I wrote it at the bottom, right? And also I can say, well, I know if this is to the power of a half, that simply means that's a square root. So I can also write this. Right, I can also write it like this. Very important. Let's jump over to part F. So part F, we are going to use this equation here, this formula here, e to the x. When you differentiate e to the x, you will get e to the x. Now, what they don't tell you when you see these formulas online or in textbook, differential of e to the x is e to the x. But you still have to differentiate the x on top here, right? But when you differentiate x, you'll get 1. And 1 times e to the x is e to the x, right? So that's why the book has this. So there are teachers who will explain that further, right? So I'm one of them. So if y equals to e to the 100, x to the power 5. So if you differentiate it in e to the x, y equals e to the x, you will get e to the x. So if you differentiate in y equals e to the 100x to the power 5, dy dx, you have to write down the same thing, e to the 100 x to the power 5. We're not finished here. Now you have to differentiate the power. When you differentiate 100 x to the power 5, 5 times 100 is 500 x to the power 4, because 5 minus 1 is 4. And when you completed this line, you simplify. So we have 500 x to the power 4, e to the 100 x to the power 5. And this here is your answer, right there. Last one, we are looking at this rule here. Well, we know sin x, if you differentiate, if y equals sin x, dy dx is cos x. If y is cos x, the differential of cos x is negative sin x. You have to pay attention to the one that have a negative sign, all right? So we have to differentiate y equals cos 3x. So let me use a little y prime. That simply means dy dx. The differential of cos x is negative sin x. So the differential of cos 3x is negative sin 3x, right? But you don't stop there. You have to deal with this here. When you differentiate 3x, you will get 3, right? So just to kind of elaborate, if you had y equals 3x, y prime is equal to, remember we have a power here, the power is 1. 1 times 3 is 3. X to the 1 minus 1, right? 1 minus 1 is 0. We know any number raised to the power 0 is 1. And 3 times 1 is 3. You don't have to do all this work in here, because your question will have a lot of working in it, right? Some working you need to do it mentally, because if you put too much working on the paper, right, some questions are complicated. When you're doing product rule and quotient rule, too many working on that paper may confuse you, right? And it's some things are unnecessary to write down, all right? So erase this. So we know when we differentiate 3x, we're supposed to get 3, right? So sometimes I tell students, when you're differentiating a variable to the power 1, whatever is the coefficient of that variable, that's the answer. And the reason is what I just wrote down here. This will be the reason, because that coefficient raised to the power 1, when you differentiate it, will be raised to the power 0, and that will be equal to 1, and you multiply that 1 by whatever number is in front. So generally, when you differentiate in a variable raised to the power 1, the answer is the coefficient of that variable, or the number in front of that variable. So in this case, if you differentiate in 3x, the answer is the number in front of the x, which is simply 3. All right. So after you simplify, and you get negative 3 sine 3x. That's the answer right there. All right. So that's it for differentiation.